Hello dear student of class 10th. Here we are going to start numerical problems. How to solve numerical of the first chapter. Okay. So it is the sixth part of this chapter. Means I am sharing with you the sixth video of this chapter. Okay. That today we will only focus on the numericals. As question first, numericals problem first. Here, the moment of a force of 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of the force. Okay. Here it has given that the moment is 5 Newton meter while force is 10 Newton. Of course, there is a point. That point is called fixed point or moment or rotational axis point. Okay. If there is a rod, let's say that if there is a rod on which a force of 10 Newton is applied, force of 10 Newton is just applied, okay, to rotate it, and this rod is hinged at a certain point, means pivoted at a certain point. Okay, what is the distance between the fixed point, pivoted point, and the line of action of force? This you have to find it. Let's say that this distance is d. Let's say that this distance is d. As we know that moment is equal to force into perpendicular distance. So moment that we represent from the tau, that is tau is equal to f into perpendicular distance. So here it has been given that tau is of 5 Newton meter, okay, while force is of 10 Newton, okay, 10 Newton. While distance is not given, we have to find it. We have to find this distance. Simple. It is so simple. Distance, here this symbol I am giving for perpendicular distance, okay. Perpendicular distance means distance and force is perpendicular to each other, okay. That is 5 Newton meter upon 10 Newton, 10 Newton, in which we will get 1.2 meter. That is, you may write it as 50 centimeter or 0.5 meter. You may write it as 50 centimeter also, okay. So this is the first numerical which I have solved on the board. Now move to the second numerical. Second problem. Second problem, it is just saying that a nut is opened by a wrench of length 10 centimeter, in which a wrench is of 10 centimeter, okay, and a nut is just opened by the help of that wrench, okay. If the least force required is 5 Newton, find the moment of force needed to turn the nut. Means it is asking you that find the moment of force needed to turn the nut. Here it has given length of the wrench. Length of the wrench means distance. Distance is, that is of 10 centimeter, okay. It is centimeter, point to be noted. You have to convert it into meter, okay. So I will convert it into meter by dividing 100, okay. It will convert it into meter, okay. Now if the least force required is 5 Newton, it is saying that 5 Newton is the least force required. Find the moment of the force needed to turn the nut. Means it is simply it has given that the least force is given. Force, not moment, that is force. Force is given. That is of 5 Newton. 5 Newton. And here is given perpendicular distance and force. And it is asking about the moment. So we have studied that moment is equal to force into perpendicular distance. So moment is equal to force into perpendicular distance. Force is of 5 Newton into perpendicular distance, that is 1/10 meter. This will come again 1/2 Newton meter. Okay, 1/2 Newton meter, and it's just equal to 0.5 Newton meter. Okay, so it is so easy to find. It was so simple that we have to use only the formula moment. Okay, now come to the next question, that is third question. Third question is also too easy. Because a wheel of diameter 2 meter is shown in the figure 1.28, which with axle at 0, means that there is a wheel, पहिया, किसी कार या किसी चीज का पहिया है, व्हील है, okay, on which at a certain point there a force applied. Okay, that force is of 2 Newton. 2 Newton. That point is B. This force, this point, at point which 2 Newton force is applied is point B. Okay. Now it has given that applied at B in the direction shown in the figure. Calculate the moment of force about the center. Okay. It has given the diameter of the wheel. Diameter of the wheel means this whole length will be called as diameter of the wheel. So the radius of the wheel. Radius will give you the distance between, perpendicular distance between force and the pivoted point. Pivoted point means fixed point. O is the pivoted point, fixed point, where the rotation on the axis, rotation of this wheel takes place. Okay, so the distance between the fixed point and the force is a radius. Okay, and we know that the radius is equal to diameter upon 2. Half of the diameter is called as radius, and here the diameter is 2 meter. So radius will be of 1 meter, and this radius will act as a perpendicular distance. So torque will be equal to force into perpendicular distance. Perpendicular distance, and that will be so easy that 2 Newton into perpendicular distance 1 meter, that will give you 2 Newton meter. Okay, this is the first. Calculate the moment of force about the center and the point A. Another second question about the center, and this moment is about the center, tau at center. Okay, about the center O, it has been calculated that is 2 Newton meter. Here in the question, here in the answer it has given it is in clockwise. I have already make you understand how to find the direction of moment. Simply you have to take point, you have to put this plumb in the direction of axis of force and just rotate into the direction of perpendicular distance, and then thumb will point out the direction of what? the direction of moment. Okay, so it will be what? In clockwise direction. Okay, the moment force will be in clockwise direction. Okay, clockwise direction. You have to use right hand thumbs rule. Okay, now again we have to find the moment at the point A. At the point A. So come to the point. Here I am just rubbing this for the second part of this question. Question third. Second part of this question. Second part. Okay. For solving second part of this question. Here is the pivoted point and it is asking point A. Let's say that the whole body will rotate. The whole body will rotate with the axis of A. There is force of 2 Newton. Now pivot point is just shifted to A. Okay. So perpendicular distance will be your diameter. Diameter will become the perpendicular distance as we have shifted the axis of rotation. So this is equal to 2 meter. Okay. So torque is equal to again force into perpendicular distance. So force is of 2 Newton and perpendicular distance is also 2 meter. That's why this will become 4 Newton meter. Okay, that is also in what? Clockwise direction. Why it is in clockwise direction? The line of action of force, will be in this direction. You have to simply put this plumb on the line of action of force and just rotate towards the perpendicular distance. That's why its direction will be in clockwise direction. Okay, that's why its answer is written is here clockwise direction. Okay, now come to the point to the next question. Okay, question number 4. Question number 4 we will do. May I rub it? Just pause it and understand by applying your mind. Okay, now come to the question number 4. It is also a simple problem. The diagram in the figure 1.29 shows that two forces F1 that is 5 Newton and F2 that is 3 Newton acting at a point A and B respectively of a rod pivoted at point O. Okay, such that OA is 2 meter and OB is 4 meter. 4 meter. Okay, calculate the moment of force F1 about O, the moment of force F2 about O, total moment of two forces about O. Okay, so it is a simple problem. There is a pivot point. There is a pivot point O and this is a rod. The end of this rod is given as A while another end is B. Okay, here it is force F2 that is of 3 Newton and here it is force F1 that is of 5 Newton acting. Okay, so let me solve this problem. Okay, please be careful while understanding it. This is a pivot point. If I am applying this force, this rod will move where? In this direction. Okay, in this direction. Why in this direction? I have already said you, please put your plumb on the direction of force and just rotate it towards the perpendicular distance. This will give you the what anti-clockwise direction. Okay, so it is anti-clockwise. Just calculate. For moment we have to apply the force. For moment is equal to force into perpendicular distance. This will be the perpendicular distance, that is of 2 meter here, and this will be the another perpendicular distance, that is of 4 meter here. Okay, let's say is a d1 and this is d2. Okay, as force mentioned. So for torque due to force F1 about O is equal to F1 into perpendicular distance d1. That is F1 is of 5 Newton into 2 meter. That will give you 10 Newton meter. Okay, that is in anti-clockwise. Okay, this is anti-clockwise as I have mentioned you. Okay dear, okay, how it is anti-clockwise? I have told you, use your right hand palm. Okay, put in the direction of the force and just rotate, curl it to what's the perpendicular distance. This will give you the, this is seriously clocks, how clocks move. Clocks moves in this direction and we are just rotating our hand in this direction, that is opposite to clocks. That's why it is called as anti-clockwise. Okay, the first part of this question is done. Second part, come to the second part. Second part, again we have to use the same formula. Torque due to F2 about O. Okay, so here is force F2 into perpendicular distance d2. Okay, that will be used. F2 is of 3 Newton and perpendicular distance is of 4 meter. Okay, this will we multiply 4 3s are 12 Newton meter. Okay, 12 Newton meter. Where will be the direction? This is our big question. Okay, simply you have to put this face in the direction of force. Okay, direction of force, and just rotate it towards the perpendicular distance. You will find that this rod will move in this side, that is clockwise direction. So here the direction of torque due to force 2 about point O, the pivoted point, will be clockwise. This will be clockwise. This will be clockwise. Okay, now select one of them is as a positive while one of them as a negative. Whatever you will select by yourself. Okay, since I am selecting this as a positive, it is sign convention. It's up to you. If you are moving to the right direction, means east direction, please select east as a positive, then west will be negative. If you will move in the west direction, then if you select west as a positive, east will be negative. In similar way you have to select it. Okay, if you take as this as a positive and this as a negative, it's up to you. Okay, that's why the total moment is equal to tau f1 plus tau f2. Okay, tau f2. Okay, I'm selecting this as a positive, means 12 minus 10, this as a negative and this as a positive. So the resultant will be 2 Newton meter. In which direction? In clockwise direction. in clockwise. Okay, so I think that we have solved these 3 questions, which will be okay. In next class we will do the next problem. Okay, bye dear.